My dear student, physics class for class 9, chapter number 5, that is state of matter and pressure. My dear student, my today's topic is Archimedes law. This is a very important law of this chapter. You know that. My dear student, this is a very important law of this chapter. Okay. At first, the statement of Archimedes law. When a body is fully or partially immersed into liquid in static position, then this body will lose some part of its weight. Part of its weight, which is equal to weight of the displaced liquid. My dear student, it is said to the Archimedes that if you keep a body inside liquid, you may keep this body fully or partially inside the liquid. But there is a condition here. That liquid must be in a static position. My dear student, that liquid must be in a static position. Then Archimedes said that this body will lose some part of its weight. And this weight loss will equal to, my dear student, please turn off your microphone. This body will lose some part of its weight. And this weight loss will equal to weight of the displaced liquid. So what does it mean? At first, I'm going to find out Archimedes law. And from Archimedes law, at first, I'm going to find out the weight loss of the body manually. Suppose, my dear students, how can I find out weight loss of the body manually? By using a body. Suppose just the body is inside the air. Then this body can feel a weight. And that weight is called weight of the body in the air. And when you keep this body inside water, you see that that body can feel some lighter weight, some less weight than that of air. So if you can, it is possible to take a weight of the body inside the water. So by using this weight, you can find out very easily weight loss by the body. And you see that weight loss by the body manually will equal to here weight of the body in the air and also minus weight of the body in water or liquid. So we can say that manually weight lost by the body, weight lost by the body will equal to what? Will equal to weight in air minus weight in liquid, my dear students. Weight in liquid. So, weight lost by the body is denoted by W lost, my dear student. Weight lost by the body is denoted by W lost. So, this W lost is nothing but weight lost by the body. I repeat, my dear student, this W lost will equal to weight lost by the body. It will equal to weight of the body in air. What does it mean? Weight in air. minus weight in liquid or water. Okay, weight in air minus weight in liquid, or you may take here water. Now, my student, Archimedes said that this weight loss also equal to weight of the displaced liquid. So you can say that according to this law, my student, according to this law, we can say that weight lost will equal to what? It said to the Archimedes that weight lost is equal to weight of the displaced liquid. So you can say that weight of the displaced liquid. Now, my students, what is the equation for the case of weight of the displaced liquid? This is nothing but, according to my last class, this is nothing but buoyancy applied on the body inside the liquid. I repeat, my student, this is nothing but buoyancy applied on this body, okay, by the liquid. So, weight of the displaced liquid at this particular place, you can say that this will be equal to weight of the or upward thrust applied by the liquid. Resultant upward thrust applied by the liquid. And this function is nothing but buoyancy applied on the liquid. My dear student, this function is nothing but buoyancy applied on the liquid. So, buoyancy applied on the liquid is known as buoyancy. That is nothing but upward thrust. Okay, my dear student, there's nothing but upward thrust. Since it is nothing but upward thrust, and you know that this upward thrust will be equal to V rho G. And this rho is the density of liquid, my dear students. Density of liquid. Okay? And this V is the volume of displaced liquid. Displaced liquid. So, according to the statement of Archimedes' law, we can say that weight lost by the body will equal to weight in air minus weight in water. And also can find out mathematically this weight loss will equal to what? It will equal to here V rho G. So these two parts are equal. So what is the mathematical equation for the case of Archimedes' law? You can say that the mathematical equation for Archimedes' law, the mathematical equation for Archimedes' law is weight in air minus weight in liquid, my dear students. Weight in liquid will equal to what? Will equal to here V rho G. My dear student, this is the mathematical formula for Archimedes' law. I repeat, this is the mathematical formula for Archimedes' law. And this is the most important topic of this chapter. So, have any confusion, my dear student, about this law? Any one of you have any confusion here?
So, right side ekhane weight in air hobe na?
Right side here, weight in air. Okay, this weight in air.
Sir, apni weight in liquid.
Okay, weight in air. Okay, very good, very good, very good. Very good, my dear student. Okay. Any one of you, my dear student, any confusion here? Any one of you? My dear student, any one of you? Any confusion? My student?
No, sir.
No, sir.
Okay, very good. Now, on the basis of this law, I'm going to solve a mathematical problem, a creative question, okay? And that should be a board question, my students. Now, I'm going to solve a board question, a mathematical problem on the basis of this law. Can I erase this board, my student? Can I erase this board?
Yes, sir.
Okay, very good, my student. So now, I'm going to solve a creative question on the basis of this Archimedes law. All of you, please take calculator so that you can calculate and solve a creative question very smoothly. Okay, my student, this is a board question. Russia board 17, my student. This is a board question that is Russia board 17. So, Russia board 17, my student. The weight of the body of volume. The weight of a body of volume 400 centimeter cube. 400 centimeter cube in air is 19.6 Newton. If it is immersed in water, if it is immersed in water, its weight becomes 15.68. Its weight becomes 15.68 Newton, my student. Its weight becomes 15.68 Newton. Okay. Now, question number C. Find out density of the body from the stem. Find out density of this body, my dear students. And now, question number D. Does the above stem support Archimedes' principle? Does the above stem okay, my dear student, does the above stem support Archimedes' law? Explain mathematically. Explain mathematically. Okay. This is the stem, my student. Is it completed, my student, to write down the stem? By the student? Is it completed to write down the stem? Okay. My student, give me some idea. How can I solve question number C? Any one of you, my dear student, give me some idea. How can I solve this question number C? Any idea, my dear student? How can I solve this question C? From any one of you? Okay, Ahnaf. Ahnaf, can you solve this question number C? Ahnaf? Give me some. Yes. Give me some idea. How can I solve this question number C, Ahnaf?
Sir, P equal to M by V.
Okay. Okay, you see that the question is here, find out density of this body. You're going to find out the density of this body. Okay, Ahnaf? Just you see that. Yes, yes.
Sir, first to sir mass বের করতে পারি স্যার। স্যার weight যেহেতু আসলে স্যার gravity তে যদি ডিভাইড করি তাহলে স্যার mass বের হয়ে যাবে।
Okay, at first very nice step. At first we're going to find out the mass of the body from the weight. Very good point. And then Ahnaf?
এরপর হচ্ছে স্যার যে P equal to M by V। প্রসেসের যে mass কে স্যার ভলিউম দিয়ে ডিভাইড করলে হয়ে যাবে।
Very good. Okay, very good idea. So my dear students, it is stated to the Ahnaf that before finding out the density of the body, the first point is I'm going to find out the mass of the body. Okay, remember please, my dear student, always mass of the body is find out from which part? From weight of the body in air. Suppose mass of the body will equal to M. So you can say that weight of the body in air will equal to M into G. So here M is the mass of the body, and here G equal to what? G equal to acceleration due to gravity. I repeat, my dear student, here G equal to what? G equal to here acceleration due to gravity. Okay. Now I'm going to find out the mass of the body. Okay. So mass M will equal to what? Will equal to weight in air divided by G. Now, my dear student, weight in air will equal to 19.6 divided by G equal to 9.8. So what's the value of mass in terms of kg? My dear student, what's the value of mass in terms of kg?
2 kg.
This should be 2 kg, okay? And now you know that the symbol of density is rho, okay? The symbol of density is rho will equal to what? Will equal to mass per unit volume. But remember, you see that the volume of this body is given at 400 centimeter cube. So we need to convert this 400 centimeter cube in terms of meter cube. Okay. So at first put down the value of mass M, 2 kg, and then volume 400 centimeter cube. If I divide it by 100 cube, then it converts into meter, my dear students. It converts into meter cube. So you need to convert this value, this function in terms of meter cube. Okay. Now, what's the density of this body in terms of kg per meter cube, my dear students? In terms of kg per meter cube. So find out the density of the body.
5,000.
So it will equal to 5,000 kg per meter cube. Any confusion, my dear student? Any one of you? Any confusion here? My dear student? Any one of you? Any confusion here? My dear student? Any confusion, my dear student?
No, sir. No, sir.
Any one of you? Anyone? My dear student? Any confusion here?
No, sir.
Okay, very good. Now you see that question number D. It said that does the above system support Archimedes law? Does the above system support Archimedes law? Okay, we're just going to justify that it will support Archimedes law or not. I repeat, my dear student, will it support Archimedes law or not? Okay, so let's justify this. বাবা বাবা ক্লাস নিয়ে আসবে বাবা। হ্যাঁ বাবা ক্লাস নিয়ে আসবে। Okay, my dear student. Now, question number B. According to Archimedes' law, we can say that weight in air, now it is water, weight in water, weight in air minus weight in water will equal to what? Will equal to upward thrust or buoyancy. Will equal to upward thrust or buoyancy. Suppose this is equation number 1. If the left side of this information will equal to right side, then definitely we can say that this system will support Archimedes' law. I repeat, my dear student, if the left side will equal to right side, okay, then we can say that this given information can support Archimedes' law. At first, I'm going to put down the values in left side from equation number 1. So, weight in air minus weight in water, my dear student. Weight in water will equal to what? Weight in air, this nothing but given in the stem is 19.6 Newton minus weight in water is given 15.68. So it is 15.68. Now what is the value from the left side, my dear student? Weight in air minus weight in water. This is the mechanically weight lost by the body.
3.92.
So it will equal to here 3.92 Newton. Now, my dear student, in right side, this is the upward thrust or buoyancy. You know that the upward thrust or buoyancy is nothing but V rho G. What is V here, my dear student? V is the volume of the displaced liquid. You see that the volume of the body is given, and that is 400 centimeter cube. Okay, so you can say that this volume V will equal to what? 400 centimeter cube. And what is rho? Rho is the density of the liquid. Now, I'm just taking water. Okay, if I'm taking water, then what will be the value of density of water, my dear student? I'm just taking here water. Then what is the value of the density of water, my dear student? Density of water will equal to what? My dear student, what's the value of density of water?
Sir, 1000 kg
1000 kg meter per
cube.
Kg per meter cube. So this is 1000 kg per meter cube. So here volume V equal to at first 400 centimeter cube. So how can I convert this 400 centimeter cube in terms of meter cube? So divided by its 100 cube multiplied by density rho, my dear student. Density rho is nothing but 1000 kg per meter cube. So this is 1000, okay? And then G equal to 9.8. So what is the buoyancy or weight of the displaced liquid? I repeat, my dear student, what is the buoyancy or weight lost by the liquid?
Sir, 3.92 Newton.
It will equal to here 3.92 Newton. What does it mean? The given information support Archimedes' law, because you see that weight lost by the body will equal to here weight of the displaced liquid. So since weight lost by the body will equal to weight of the displaced liquid, that's why you can say that this given information support Archimedes' law. I repeat, my dear student, this given information support Archimedes' law. Okay, have you any confusion, my dear student? Have you any confusion here? Any one of you have any confusion here?
No, sir.
No.
Okay. If I change the data, I repeat, my dear student, if I change the data, Then let's see. Can you solve a creative question just like this? Suppose, my dear student, this is 300 centimeter cube. Suppose this is 300 centimeter cube. And weight in the air is given. It is 9.8 Newton. So this is 9.8 Newton. Okay. And weight in water is here 7.8 Newton. So this is 7.8 Newton. Okay. And this also board question, Dhaka board 17. My dear student, this is a question for Dhaka board 17. Then let's see, can you solve this question or not? My dear student, let's see, can you solve this question or not? Okay. I'm going to give you 5-minute time to solve this question, my dear student. I'm going to give you 5-minute time to solve this question. So, my dear student, this is the pathway. You can follow this. Mass m into g. Weight in air will be equal to what? M into g. So, what is the value of mass of the body? It will be equal to weight in air divided by g. So, this is weight in air equal to 9.8 divided by 9.8. So, mass of the body will be equal to 1 kg. Now, my dear student, the density of the body. So, density of the body will equal to what? Will equal to mass per unit volume. Now, mass is given, and that given mass will equal to what? Given mass will equal to 1 kg. And volume, you see that it is a volume that is 300 centimeter cube. So divide by 100 cube will equal to something kg per meter cube, my dear student. Now find out first the density of this body. My dear student, make it hurry. Now find out the density of this body. So what is the density of this body, my dear student? Rose, what is the density of the body?
Sir, 3,333.33.
3,333.33. So this is 3,333.33. Okay. Is it correct, my dear student? Other student, check it, please.
Yes, sir.
Okay, very good, Rose. Now, my dear student, question number D. You are going to justify that this given information support Archimedes law or not. Just like previous one, you can say that weight in air minus weight in water will equal to what? Will equal to upward thrust. And suppose this is equation number 1, my dear student. And suppose this is equation number 1. So I'm going to solve I'm going to put down the values from left side, at left side, okay? So at left side, you can say that it will equal to weight in air minus weight in water, okay? Now, weight in air equal to what? You see that weight in air equal to 9.8 Newton. It is 9.8 Newton minus weight in water equal to what? It is 7.8 Newton. So it will equal to 2 Newton by a student. It will equal to what? It will equal to here 2 Newton. Now put down the value at right side and let's find out the buoyancy force or upward thrust. So the buoyancy force or upward thrust, F upward, will equal to what? This is V rho G. It is said to the stem that volume of the body is 300 centimeter cube. So this is 300 centimeter cube divided by 100 cube. Density of water is 1000 and G equal to 9.8. Now find out
2.94.
it is what?
2.94 Newton.
Is it 2.94 or 1.94?
Sir, it is 2.94.
2.94. Okay?
Yes, sir.
Please take this equation carefully, my dear student. Please check this equation carefully. Because we're going to make a conclusion here. It can support or not. Okay, this given information can support or not. That's why please just confirm that is it 2.94 or is it 1.94?
Yes, sir. It is 2.94.
Okay, it's 2.94. Okay. If it is 2.94, so definitely we can say that this given information doesn't support Archimedes law. My dear student, definitely we can say that here, this given data, this given values, it doesn't support Archimedes law. Okay? Any one of you, my dear student, any confusion? My dear student, any one of you, any confusion from your side?
No, sir.
Okay, my dear student. So this is all about my today's class. See you at my next class.